Okay, hello. Let's talk about the form for bridge structures, the concrete form and the concrete curve form. So, couple of things we need to talk about it. There's some few difference between the way we handle the concrete placement in bridges and the way we handled before for miscellaneous structures. Right? We will point out the differences, and you will notice there are some couple of things here that are different from the miscellaneous structures. Right? This form was adjusted to handle the possibility of the contractor using two cases. In this particular case, you may have an internal casing and the external casing. We typically will call this in our form, we're going to call this casing 1, and we've been calling this casing 2. This is particularly typical when we have to do shafts in bridges in water, when the contractor will drop an oversized casing and he would put a as a permanent casing, and then inside that permanent casing, he will use a temporary casing with the diameter equal to the minimum size required by the plans. Alright. Then he will pour the concrete, he remove the internal casing, and then he will continue pouring concrete till final elevation of the shaft. So in this concrete placement form for bridges, you will notice there's a column here that we have called new reference elevation. Alright. In this particular case, we will have to input the reference or top of the casing elevation, even if that doesn't change. For example, we may have started somewhere here, our original cutoff elevation, but as we start pulling the casing, we may have, after a certain number of trucks, we may have risen this elevation to this elevation here. So this will be our new reference elevation, and whatever the concrete finish at the end, the inspector or a concrete operator will tape this measurement, and that's what we enter as the dead below reference. Let's see this example here. In this case, the pour started with a reference elevation at +9. Okay? So after several trucks, so we kept here, the contractor kept the same elevation. After several trucks, the contractor decided to raise the casing to this elevation 2062. And then we measure the depth below this elevation, and then the spreadsheet is going to calculate this one. You don't have to do anything on this column, and I'm going to tell you later on what this is about. Then after this truck was poured, then he raised again to 3045. We poured concrete, and then we measured concrete 24 feet below this elevation now. And the spreadsheet internally does that. You don't have to do anything here. This actually means calculated depth to concrete below the original reference elevation. This would be, this would be the depth elevation that we will have here below the original line. All right, but don't do anything. This is done only for the purposes of plotting the curve correctly later on. So then after this elevation, basically he pulled the casing completely out, the internal casing, and we ended with 561. So we ended, in this particular case, we ended with the outside casing number 2, which in this particular case was the permanent. So here there was the elevation plus 5.61. So we moved all this pour happened, the majority of the pour happened, of the concrete pour happened inside this casing, After we remove this, we end up with 5.61 in this particular case. So looking back here into the phone, so we end up with 5.61. We end up with the permanent casing reference elevation. Now let's talk about the additional casing and variable reference information. You notice outside the viewable table, there's another table where we're gonna input the casing length. Right? We input either temporary, permanent casing length column. We will input the temporary casing 1 information first. After the casing 1 is removed, we will input the casing information from casing 2. So what's going to happen here in this particular case, at the beginning the casing is 70 feet depth in this particular case. All right, let's do it here, 70 feet. When we started raising the casing here, after we raise it a little bit here to 20.62, then for the next step we cut it off. So we use this as a reference, but now the casing length is only 50 feet. And after we remove the whole thing, this is the permanent casing, which in this particular case has a 36.63 feet long. So that's what we input here. Now this is of particular interest because the spreadsheet is going to compute what is the tip elevation at this point, how much concrete we have inside that casing above the tip elevation. This is particularly useful to make sure that there's not going to be any risk of any breaching if we don't have enough concrete inside the tremie or inside the tremie. There may be too much pressure outside the casing, which may create some breach. This particular case, that's something that the inspector may can put, if you feel concerned about 15 feet, if we input that thing. So every time we got less 15, it's gonna flag you in red. And at the beginning it's not a big deal because always, typically you're gonna have, of course, it's gonna be difficult to have 15 feet depending on how much you put here. But as you go higher, you may want to check that if, for example, in one particular case, the contractor may have cut off too much. Let's say, for example, if I have only, if I had cut this one 40 feet, I still okay. But what if I had cut 35 feet? Then I may start getting concerned. Maybe I pull out too much of casing. So it's something that allows us later on, if there is an issue, if we found some integrity issues, maybe we can investigate and see what happens. So the only thing you input here then is the length, what you have at that point of the temporary or permanent casing. Everything else is being computed. This is something that is going to be computed based on the data you input when, how much the concrete drops in certain cases. And I will explain that using this figure. Again, as you can tell here, when the concrete is inside the casing 1, which has a smaller diameter here, theoretically, if I pull this and if I don't add any concrete, the volume has to drop. So there should be some expected drops, even if there's no losses or there's no concrete lost through cavities. There should be, geometrically, there should be some drop in the concrete level. So this is what this is about. So later on, you can compare the theoretical drop was expected to be 648 feet, and I got 8 feet. So we may be okay. I would be concerned if we got less drop than whatever is anticipated theoretically, because that could mean some caves may have happened. Now let's move to the concrete curb. So a couple of things you'll notice from previous versions. We have added something called highest concrete elevation in casing 1 during pour, and the theoretical top elevation that you expect in the shaft. And there is something that it will tell you here what that means. Let's see, for example, there's an explanation here. There's an explanation that says when 2 casings are used, enter the highest elevation of concrete inside casing 1. When approved by the engineer, this may be lower than the reference elevation. Right? And this could be the case here. For example, you may have thing here, but the contractor decided I'm just gonna stop somewhere here. I'm not gonna go all the way here. That's what that means. And now let's see what is this. What is the explanation of this one here? This is theoretical top elevation of the shaft in casing 2, which would be equal to the top elevation to calculate the theoretical volume. It may be lower than the reference elevation in special cases. Let's see what does that mean. For example, in this picture, the top of the casing is somewhere here, but the concrete is pouring here. So if this is the final casing, the casing number 2, or in case you only have one casing, and this is it. So the top of the shaft could not be greater than this elevation, could not be higher. So this would be your top elevation, even though your reference may be somewhere here, but this is it. This is what you aim for. It could be lower, it could be, whatever is this elevation, you would input that as what would be theoretically the top of the concrete during the pour. So let us explore this curve here. This is the theoretical. Okay, let me reduce a little bit the scale so I can show you the whole thing. Okay, so we start with some, in this particular case, I think the casing, it didn't go all the way, for example, all the way to the bottom of the casing, but we got a theoretical given mostly by the excavation and casing 1, and we go to here. This one, it is the highest elevation we were pouring to inside the casing 1. Okay, so of course the theoretical is going to stop here. This is the theoretical volume that the concrete will follow if nothing happens, nothing out of the ordinary. If you get a full casing, for example, and then in that concrete, I do expect this to follow this path. Right? Now, when we remove that casing, of course the concrete is going to drop for the same reasons I explained before, and then it's going to follow the slope of the outside casing, which is casing 2. In this particular case, I'm saying here 561 is the limit of this one. What happens if I input, for example, here, in this case 561, so of course this is the limit in casing 1. I'm limiting this to 561 or whatever. Let's say I input 2, so it's limiting that thing. So let's come back to 9, okay? So what happens if I limit this to 1, for example, and it drops, it just doesn't even feel. So let's what happens if it's I input 3, so it go right there, it draws pretty much the 8 feet, and it's kind of tries to come back a little bit. Let's come back to 561, and it keeps going. Now values, this value cannot will not go higher in the chart, will not higher than whatever we input here as the highest value, okay? Will not be higher. All right. So if I input, even if I input here 9, the theoretical won't go beyond 561 because I input here 561. All right. If I input here, for example, 7, now it's gonna go up to 7. It don't go all the way to 9. If I input 9, now I went all the way to 9. So this value here is limited by the value I have input here as the top of the casing on casing 2. So, all right. Come back. Now you notice something here. This is the theoretical drop after I remove casing 1. So as we saw before in the figure, it has to drop. You see a difference from it doesn't go all the way to the theoretical line because of the thickness. If I was going to input this thickness that we input here on the thickness here is key. If I was going to input only 0, if I didn't input any thickness at all on casing 1, so that's what you have. You will have completely go back to the theoretical. but because there is some thickness on, the thickness also takes volume, so let's put 0.5 inches again. So the concrete curve will drop a little more because of the thickness of the casing. And this could be, important, especially in very deep casings. So summarizing, in this figure, which is in page 25 for your manual, we got the explanation of this value. So here it is, 9. In this particular case, we put +4. So you can see the effects of what this curve represents. For example, we got here in this particular case an encased portion, and the bottom of casing 1, it continues this line. Again, by the diameter of casing 1, it drops here. Now this slope here actually is in dotted line. It follows the diameter of casing 2. This is bottom of casing 2. The theoretical volume will follow this path up to, we remove the casing. Once we remove the casing 1, it drops up to here, down here, and then it will follow this slope, which should be parallel to the casing 2 diameter. All right. Now finally, there is an additional page we need to see. You see this tab? It's called additional casing reference. You don't need to input anything here, okay, except maybe page so and so, but that's the only grade you have. Other than that, this is gonna basically copy whatever you input here on this table outside the placement table. So this was outside the viewable, but just to keep the record what you input here, this is gonna basically repeat and type itself again in these pages. So, all right. And of course, if we have used 3 pages, you will have 3 tables, so it will copy 3. In this particular case, we only have 1 table. All right. And I think that's pretty much it what we have for this thing. Thank you very much.